Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we are going to study about the instrument digital voltmeter, which is used for the measurement of AC and DC voltages. In this video, we are going to study the block diagram, construction, working, and the advantages and the types of digital voltmeters. So let us start with our topic. Before starting with the digital voltmeters, first we will study that what is a voltmeter. Voltmeter is an instrument which is used to measure the potential difference between 2 points. Now the voltage which is measured, it can be an AC voltage or it can be a DC voltage. Now there are two types of voltmeters. One is the analog voltmeter and second is the digital voltmeter. Both these voltmeters, they can measure the AC and the DC voltages. The difference between the two is that the analog voltmeter, it is going to give us the reading of the voltage on a scale. There will be a pointer. This pointer will be deflected over a scale, calibrated scale, and we can read the readings from this scale. Whereas the digital voltmeter, it is going to give us the direct reading, okay, means it is going to provide us the discrete numerical value of the voltage, okay. So that is the difference between the analog and the digital voltmeters. One is the analog and second is the digital. Let's see the difference between the analog and the digital voltmeters. So analog voltmeter, it is going to contain a dial with a needle, and this dial is going, or we can say the pointer, it is going to deflect over a calibrated scale. Now this needle, it is going to move over the scale according to the value of the input voltage, okay. So whatever will be the value of the voltage, the needle will be deflected in proportion to that. So we can say that the reading which we are taking from the analog voltmeter, that will be equal to the input voltage, okay. Now digital voltmeter, it provides us the direct reading. It is going to give us the direct discrete numerical value of the voltage. Now in the analog voltmeter, as we are as the observer, it has to read the readings. It has to take that where the needle is pointing over the calibrated scale. So there may be errors which can occur due to the wrong observation of the observer. Okay, whereas in the digital voltmeter, because it is directly providing us the reading, like if the voltage is 21.1 volts, so we can directly read these readings. So there are less chances of errors in the digital voltmeter, whereas in analog, because the observer, it has to see that where the exactly the pointer is coinciding with the divisions on the scale, so it has to read that scale, so errors can occur in that. So analog voltmeter. So here in analog voltmeter, there are chances that the scale may be wrong or wrong readings can be taken. Whereas in digital voltmeter, there is no doubt in taking the readings because we are getting the direct numerical value. Now in analog voltmeter, the number of scale divisions, it will be means it will be limited. Okay, but in digital voltmeter, the resolution will be more superior because the number of decimal values which we are getting after the decimal points, it will be more. It is going to give us the exact value. Like if we are having 21.101 volts, so that will be directly indicated or correctly indicated by the digital voltmeter. But if we have to read this minute value, that 0.101 voltage from an analog voltmeter, that will be difficult for us because it is going to give us the values in like millivolts only. Okay, but less than that value will not be indicated on the analog voltmeters, so its accuracy will be more. Digital voltmeters, they will be having more accuracy and superior resolution in comparison to the analog voltmeters, because the scale reading, it is limited in the case of analog instruments. Now, if we want to read a voltage which is having a negative value, so that negative value can be correctly indicated by a digital voltmeter, because in digital voltmeter we are having the facility of indicating that whether we are getting a positive value or a negative value. So if we are having a voltage which is minus 21.1 volts, so that will be indicated by digital voltmeter. But in the case of analog voltmeter, which is having a scale which is starting from suppose 0 to 20 or 50 volts, which is having the scale range as 0 to 50 volts, and if we want to read a voltage which is in the negative side, so the pointer will try to deflect in the left hand side from the 0, but it is not going to indicate us the proper value. But the digital voltmeter, it will correctly indicate that whether it's a negative voltage or a positive voltage, and it is not going to give us any error. So next difference will be that negative voltage will be correctly indicated. Another difference between digital and analog voltmeter is that in digital voltmeter, there is no damage. No damage is going to occur if this instrument is going to fall from the table. But in analog voltmeters, if this device it falls from the table, it is going to be damaged because the scale will be disturbed, and also this scale is having a glass over it. So that glass will be broken. So in the analog voltmeters, we cannot roughly use the instrument, whereas digital voltmeters, they can be roughly used by the observer because no damage will occur if it is going to fall from the table. So that is the difference between the analog voltmeters and the digital voltmeters. Now here in this video, we are going to study in detail about the digital voltmeters, that what is their working, what is the construction, what are the various components, advantages, and the various types of digital voltmeters available to us. The digital voltmeter, as I have said, that it is going to measure the voltage and it is going to give us the output in the numerical value. Okay, discrete numerical value, it is going to give us the output or the value of the input voltage. And also these digital voltmeters, they are very versatile and accurate instruments which are used in the laboratories, and they are widely used for the measurement purpose because their size is very less, they consume very less power, and also their cost is very less. So we can say that the digital voltmeters, they are very versatile and accurate instruments. Because of their reduced size, less power consumption, and less cost. So due to these reasons, they are most widely used in the measurement applications. Now let us come to the block diagram of the digital voltmeter. Digital voltmeter. You can see here that the various components in this block diagram are an AND gate, inverter, counter, decimal display, and pulse generator. The input voltage which we want to measure, it is applied to the pulse generator. This pulse generator output is given as one of the input of this AND gate. Another input of this AND gate will be a rectangular pulse. So both these inputs are applied to the AND gate. Output of the AND gate is given to the inverter. The function of the inverter is to invert the waveform. So you can see that the output waveform is inverted form of the input. Then the output of the inverter is given to the counter, and the output of the counter will be displayed here. So that is the block diagram. Let us study these components in detail. The input signal is basically the signal whose voltage we want to measure. So here, input signal is the voltage to be measured. Then we have the pulse generator. Pulse generator is a voltage source. The input voltage, it is applied to the pulse generator. It is going to use the digital, analog, and both types of digital and analog techniques so as to generate a rectangular pulse, and this rectangular pulse is given as an input to the AND gate. You can see that input voltage is applied. Pulse generator is going to convert this input voltage. It is going to apply some digital and analog techniques over this signal and going to convert it into a rectangular pulse. Okay. Now this pulse generator, because it is going to use both the digital analog techniques so as to convert this input signal into a rectangular pulse. Okay. So digital techniques, they are going to control the width and the frequency of the rectangular pulse, and the amplitude and rise time and fall time of the pulse, they will be controlled by the analog circuitry. Okay. So this is how a rectangular pulse will be generated by this pulse generator, and this rectangular pulse will be according to the input signal. Now the next component is the AND gate. Now the output of the AND gate will be high when both the inputs are high. Means when both the inputs are at logic 1, then the output will also be at logic 1. Now here you can see that in this block diagram, the AND gate, one of the input is the rectangular pulse which is generated by the pulse generator, and another input is a train of pulses. Okay. So when both these input are given to the AND gate, then this rectangular pulse, these train of pulses, they will have the same duration as that of this rectangular pulse. So this you can say that this AND gate is modifying the train of the pulses according to the rectangular pulse given to it. Okay. So AND gate, it is having two inputs. One input is the train of pulses and second input is the rectangular pulse given by the pulse generator. So the output of the AND gate will be a train of pulses which is having the same duration as that of the rectangular pulse. Okay. Next, we are having, after this AND gate, we are having an inverter which is going to invert the waveform. Then we are having the counter which is going to count the number of pulses. And after that, we are having a decimal display. So this counter and the display unit, what it does, it is going to count the number of impulses. Here you can see that these pulses are going to pass through the counter. So it is going to count these number of pulses and then it is going to display them over the LED. So this number of impulses, it will be equal to the input voltage. Why? Because this train of pulses, after passing through the AND gate, only those number of pulses which are of the same duration as that of this rectangular pulse, so only the number of pulses which are equal to this input voltage, that will be passed. Okay, so counter is going to count them and it is going to give us the value of the input voltage by calculating the number of the pulses passed through it. Okay, so in this way, this digital voltmeter, it is going to give us a numerical value of this input voltage. Now let us come to this was the various components of this block diagram. Let us explain this working of this digital voltmeter. Okay. Now this output of the pulse generator is then given to the one leg of AND gate. Another input to this AND gate is a train of pulses. So AND gate, it is having two inputs. One is the rectangular pulse and second is the train of pulses. So output of the AND gate will be a positive triggered train which is of the same duration as that of the rectangular pulse. Okay, so this train of pulses is modified according to the width of this rectangular pulse. Now this positive triggered train is now given to the inverter. Inverter is going to convert it into a negative triggered. Okay, the positive trigger train is now converted into a negative triggered train. Now the output of the inverter is given to the counter. What the counter does, it is going to count the number of triggers in the Okay, now this number of triggers in the pulse, they will be equal to the input voltage. And we can calibrate this counter so that we can directly read the value of this input voltage in volts directly from the display unit. So this is how the digital voltmeter works. So you can see that the working of the digital voltmeter, it is nothing but equal to the conversion of an analog signal into a digital signal. Analog signal was the input signal voltage, okay, input signal, and that input signal is converted into a digital signal, and means that what this digital voltmeter does, just an analog to digital conversion is there. So this complete block diagram of this digital voltmeter can be replaced by a to D converter. So the analog signal, it is converted into a train of pulses, and we are going to calculate the number of these number of pulses in that train, and that will be equal to the input signal voltage. So here digital voltmeter, it can be replaced by a to D converter. Here we will have the probes. This is the attenuator and amplifier. So through these probes, we are reading the input voltage. Then this signal will be amplified. It will be converted into a digital form by this analog to digital converter, and the digital display is going to give us the value of the input voltage. So that is the complete working of the digital voltmeter, which is described in short, that this working is nothing but an analog to digital conversion of the input signal. Now let us come to the advantages of the digital voltmeter. Why the digital voltmeter is preferred over the analog voltmeter? when the operators use analog voltmeters for measuring the input voltage, they have to take the readings by reading the scale, the calibrated scale, and this scale is having many divisions over it. The analog voltmeter, it look like here we are having the box in which we are having a dial, a pointer. This pointer is moving over a scale. Now this scale is having various scale divisions over it. So these scale divisions are very minute. Okay, suppose that this is having the range to measure from 0 to 50 volts. So observer, when it is reading this, because this instrument is having a glass over it, so that it is a transparent glass, so that the observer can read the readings from this instrument. Now if there is any error like a parallax error, if it is not reading just at a level of that instrument, so there may be error that the observer may not read the correct reading. Whereas in digital voltmeters, because we are getting the direct reading of the input voltage, the observer just has to read that numerical value, so errors are reduced. Okay, these errors are called the observational errors. So observational errors are eliminated in the case of the digital voltmeters. Also, errors on account of the parallax and the approximation, they are also eliminated. Parallax means that if the viewer is taking the readings from different levels, like an upper level, if the instrument is kept at a lower point from the eye level of the observer, so in that case also the error will occur. If the instrument is kept at a higher level than the eye level of the observer, then also error will occur. It is going to take a different reading. So that type of error is called the parallax error. Approximation means that not accurate value can be read. Suppose that the scale divisions, they are minute and they can read the voltages up to the 50.1 volts value, okay, up till 1 decimal point. But the digital voltmeters, suppose if the actual voltage is 50.123 volts, so that exact value can be read through the help of DVMs, that is digital voltmeters. But such type of value will not be read by the analog voltmeters, and the observer is going to make an approximation that the voltage is close to this 50.1 value. So these types of errors are eliminated in the case of digital voltmeters. If in the digital voltmeters, memory storage devices are also connected with them, so the output of the DVMs, it can be stored in the memory and it can be used for the future computations. So output can be fed to the memory device for storage and future computations. Also the DVMs, they are very versatile, accurate, cheap and compact devices. They are very accurate, they give us the accurate reading. They can be used in any type of environments. No error will occur if the device is going to fall from the table. Also they are very their size is very less, so they are very compact and the portability is increased. We can use them anywhere in the laboratories or outside the laboratories, they can also be used. Their power requirements is very less. So these are all the advantages of the digital voltmeters. Now next we will study the types of digital voltmeters which are available to us. There are 5 types of digital voltmeters. So these are the 5 types of digital voltmeters available to us. In these type of digital voltmeter, there are various techniques used to measure the input voltage, and depending upon the technique used, their names is being decided. Okay. So there are 5 types: ramp type, integrating type, potentiometric type, successive approximation type, and continuous balance type digital voltmeter. So this is all about the digital voltmeter. In this video, we studied that what is a digital voltmeter, what are the types of voltmeters, analog and digital voltmeter, the difference between the two. Then we studied the construction, block diagram, and the working of the digital voltmeters. In the last, we studied the advantages and the types of DVMs available. So I hope that this topic, digital voltmeter, it is now clear to you. Thank you.